In order to help newcomers to the world of embedded system security, I have created this tutorial. The goal is simple. I bought a brand new TP-Link router, hence the name of the tutorial, TP-Link Router Analysis. We will go on a journey together to explore what tests we can conduct and how to set up our environment for further analysis. Throughout this tutorial, you will see at least 3 main windows. Here on the left, this is a live camera feed on the router itself. I just took the board from inside the case. Here on the right, it's a presentation just to provide structure to the video, and of course here our terminal. To give you an overview on the topics we will cover in this tutorial. In this first video, we will talk about attack service and connecting to the device. In the second video, we will analyze the printed circuit board, DHCP, and identify the UART and read the boot logs. In the third video, we will dump the firmware from the flash memory. And in the fourth video, we will extract the Linux kernel and the root file system. And in the fifth video, I'm thinking about analyzing the Android app that comes with this router. First, let's discuss the attack service. And by the way, this is a common interview question because identifying the attack service helps us to identify any potential entry point on the system and focus our work on weak or vulnerable areas. Also, this router, or actually any other embedded devices, seems small, but actually there are many factors to consider. For example, the hardware level. It is important to check if there is any debug ports left on the device, like any UART, any JTAG, SWT, etc. And on the network level, we need to understand what other devices communicate with our device. Maybe here in this scenario, the routers only communicate with my computer, but for example, in my work, an ECU is always in communication with many other ECUs. So it's important to identify and analyze this network activity. And of course, what about the operating system in use, along with its hardening and security measures, if there is any actually. And many embedded system devices run web application at least for maintenance purposes. And increasingly, we see nowadays many embedded system devices come with Android apps that interact with the device. All these aspects, all this domain contribute to the attack service and make it wider, and we need to be aware of all this. First, device info, as usual in any kind of pen test engagement. First, let's collect a few information about our device. As I mentioned, it's a TP-Link. The module is Archer A5. It comes with Android app that set up also the router. When you open the box, you would see it. Okay, the router, there is one Ethernet cable and the power supply here. And here also you can see there is 4 LAN and 1 WAN. This is here because this router could be used as an extender. That means it can connect to another router. And at the bottom of the router here we can see the MAC address, the wireless pin, and the SSID. There are 2 SSID, one in the 2.4J and one in the 5J. And here the IP address of the router, or you can reach it also through this link, the HTTP TP-Link Wi-Fi.net. Wired connection. So now the question how we connect to the router. Usually in this case we will use the provided Ethernet cable for a direct connection between our computer and the router. And once we plugged the cable, like a new network interface here will appear on our machine. It might have the name ETH1, ETH2, or maybe different name based on what operating system you are using. In my case, it will be ETH1. And don't worry, we will see that in action shortly. Typically, we need to configure our network interface to be on the same subnet as the router, so in order to communicate between each other. However, with this router, that's done automatically, which is something we need to explore to understand how this happened. So let's move to the terminal, and just to know now the router is not connected yet to my machine. Maybe I can run first ifconfig. So this is my machine interfaces, and before I plug in the router, I will run this command watch-n1 and then ifconfig. This is just monitor the output of ifconfig, and it refresh every 1 second to see if any change happening here. So I run this command, and I will use also another tool, the Wireshark. Wireshark is really a strong tool which allows us to capture network traffic. Now because I don't have ETH1, so let's plug now the router cable in my machine, and you see here now I got ETH1, doesn't have any IP address yet. So let's go back here to the Wireshark. You see now ETH1 it's appeared here. So I will double click on it, and now Wireshark is listening on the wire. Okay, so now we are ready. Wireshark is here, and watch ifconfig is here. What I will do now, I will turn on the router. You can see here I'm pressing the button, and the light, the LED went on shortly, because now we know the router is booting up. You see here a little bit traffic now coming, and if I make this bigger, also you will see some traffic coming on the network. This may take a few seconds until the router configure our interface and assign an IP address to it in order to be able to communicate with the router. And okay, now we see that connection established, and if you notice here, now the ETH1 got this IP address now. What that's mean, okay, now if I try to ping -i, because I'm using ETH1 and I want to ping 192.168.0.1, this is the IP address of the gateway, the router. I will see I'm pinging it, and also you will see here in Wireshark. So I will stop it here, and I will stop the capture. So here all the traffic went, or the packets went back and forth between our computer and the router. I'm not interested in currently in the ICMP version 6. So I will filter on that, and you will see this is the communication until here our computer is ready to ping the router. So let's analyze here what happens here. Actually, let's go back to our presentation. So that's exactly here the packets. First packet here, our device sending a DHCP request. Okay, DHCP is Dynamic Host Configuration Protocol. This is a client-server protocol that automatically assign IPs to any new device join the network. So here our computer, why the IP is 000? Because still our Ethernet ETH1 doesn't have an IP. So now it's sent broadcast to ask if there is any DHCP server. So that's why it's called DHCP Discover. And after that, here we see the IP address of the router, because the DHCP on the router has heard that someone asking for the DHCP server, and it responds here to our device with this IP address. So this is called a DHCP offer. Why? Because the DHCP server of the router responds with an offer to our device, proposing this IP address would end with 100. Now, third message, our device here accept our computer requests the offered IP address from the router DHCP server. This is number 3, DHCP request. Now we are requesting this IP address. Because our computer accept the offer, now the TP-Link router broadcast an ARP. Now see, now a different protocol, address resolution protocol, because now the router wants to know the MAC address of the device who accepts this IP, the one end with 100. So that's why it sent an ARP request. And here in message number 5, actually here our writer also acknowledged that our computer accept this IP address. So that's why this is a DHCP acknowledgement. What happened after that is that our computer, so this represents our computer, broadcast an ARP packets to on the network, asking if any clients have this IP address. This is why it's called, this is ARP probe. Our computer is probing to see if there is any client on the network who has the same IP address, because we don't need IP conflict here. And because there is no any request, now you will see our computer send or broadcast an ARP announcement. You see ARP announcement for this IP address, like saying, hey, now I am the device who has this IP address. And what happened after that? Now we see also our device sending an ARP request asking who has the MAC address of who has this IP address, because our computer wants also to know the MAC address of the MAC address of the router. That's why here you see in the final message the router responds that this IP address is on this MAC address. So at the end of this process, both the router and our computer obtain each other's IP addresses and MAC addresses, and that's preparing them for communication. That's why I was able to ping the router. So let's see that's in action. Now let's start browser and let's go to 192.168.0.1. Now I can reach the TP-Link dashboard. Actually, the first time you start the router, it will ask you to create a login password, and just you provide the password and then you will be logged in. So this is the same case here. Once I provide the password, then I will be logged in. Here we can see another information like the firmware version of the device, the hardware version, this is V6, and this information we already know, the MAC address, the IP address of the router, the subnet, and of course the two wireless, one on the 2.4 and one on the 5 gigahertz, and yeah, of course, many other information here on the router dashboard. So now we are able, or we connected successfully to the device. As a summary, in this video we learned about our target for this tutorial. It will be a TP-Link router, Archer A5. We know its IP address and its MAC address, the firmware and the hardware version, and also we know the pin for the password for the wireless and the name of the SSID. This is for now. In the next video we will analyze the printed circuit board and identify the UART. So for now, thank you for watching, and I see you in the next video. Bye bye.